So today we are talking about solving logarithmic equations. We're going to be using the properties that we talked about last class to solve these different equations. All right. So the properties I'm referring to are the multiplication rule, quotient rule, power rule, also those special rules as well, and also using the skill of converting from logarithmic form to exponential and back, okay? So let's start it off, okay? Solving logarithmic equations, okay? There's two different types of logarithmic equation that you can have. You can have the one where there's a log on one side of the equal sign, or you can have it when log is on both sides of the equal sign, okay? So if you're looking like, wait, where's the words we fill in? I blocked them to make sure that you guys are listening, okay? Because I might throw in some additional information, all right? So the first thing you want to do, if it's the log on one side of the equal sign, okay, you want to make sure that you isolate the log. In other words, you want to get the log by itself, okay? And or apply properties to condense or expand the logarithm, okay?
When you say isolate, does that mean it can't have a coefficient like 3 log?
Correct. It has to literally be just the log base whatever by itself on one side. That's what I mean by isolate. So if there was like a +3 that was added to that log term, then you would have to get rid of that. Or like you said, if there's a number in front, you got to get rid of that.
But what if you have the exponent 3? So like, what do you do?
If you have an exponent, that's fine. Exponents are fine.
No, I'm saying like, you know how like when you have the like so you have like x to the third, then you have to bring the 3 out in front of the log.
Are you saying say this is what you have?
Yeah, and then you make it 3 log.
You do not have to bring it to the front. You do not. You can actually leave it the way that it is, like so, because technically this is log of x to the third. That's technically what that is, okay? And so technically the log is by itself, so you can work with it like that. All right. Next thing you want to do is after you've isolated the log, you want to rewrite it in exponential form. Okay, we practiced that in your do now. We practiced this some the last class. That's when you do the loop trick. You want to write it in exponential form because it'll basically be log base of something equals a number. You rewrite it in exponential form. After that, the last two steps are pretty simple. You'll want to solve for your variable at that point. And then you always want to make sure that you check your solutions. The reason why you check your solutions is because you cannot take the log of every type of number. To be more specific, you cannot take the log of a negative number or 0. I'll say that again. You cannot take the log of a negative number or 0. So that means that when you get your solution, you want to plug it back into the original equation. Because if it just so happens that it simplifies down to be log of -3, well, you can't do that. You can't have that. Okay? You cannot take the log of a negative number. So in that case, that wouldn't be one of your solutions. It would be extraneous. Okay? So you cannot take the log of a negative number or 0. Now, if the log is on both sides of the equal sign, again, you either want to condense or you want to expand if necessary. Sometimes it won't be necessary, but if you do have to do it, then you want to do it.
How do you end up with the log?
So let's say the problem was like log of x equals log of 3. Say it was something like that. This is where you would have a log on both sides and ask you to solve for x. I mean, this is the most like basic, simple example, but.
No, I'm saying like, how do you end up with it like that? Because when you rewrite it in exponential form,
Oh, no. This is like a different situation. So yeah, so now we're talking about where there's a log on both sides. Okay? So this one would be if you had a problem like so. This one would be if you had logs on both sides. Yes. Yeah. That is an option. That is an option that you could do. But if there's a number on the other side, then you don't want to do that. You want to condense instead. But once you've gotten a log on one side, one log on the other side, then you want to set the two arguments equal to each other. And by arguments, I'm talking about this part, the part that the log is attached to. So you want to set those two things, the arguments that are circled in purple, equal to each other. You would solve for the variable, and of course, just like before, check your solutions. Okay? No, these are, they're called arguments. So if I wanted to, I could plug in a base of 4. All right? Always check your solutions, because again, you cannot take the log of a negative number or 0. So let's solve. Here we go. Now, the first one, it is ln, right? Okay. First one's ln. ln is just like a log. So those rules apply as well. Okay? This one, you have a log or ln on the left side, you have an ln on the right side, and you only have one of each, correct? So this would be the second situation. You have a log on both sides, okay? There's no need to condense anything or expand anything, okay? There's no need to do that. So then we go to step 2, which says to do what? Set the arguments equal to each other. So you just said 2x plus 1 equals to 3x, and then you solve it. Subtract 2x over, and x equals 1. Now that would be my solution, but I want to make sure that I check it, okay? So I go back to the original problem and I plug in 1 for x. In order for this to be true, the left side, of course, has to equal the right side. 2 times 1 plus 1. So this is the ln of 3 on the left, and what's 3 times 1? Are they equal? So then 1 is my answer. And I'm not presented with something like the ln of a negative number, because ln still, you cannot take the ln of a negative number, and you cannot take the ln of 0. It applies for both. Questions? No. It's like on the same line as the ln. Let's look at this one. I have a log on the left, a log on the right. No need to condense or expand. So what do I do from this point? Set the arguments equal to each other. And if you noticed as well, the bases do have to be the same in order for you to solve this. If the bases are different, you're not going to be able to solve it. If they're different, that probably means I typed it in wrong. So you might want to double check with me. Okay. Solve it. Negative 6 equals x. You want to make sure you go back in and check your solution, okay? So this becomes log base 3 of negative 6 minus 6 equals log base 3 of 2 times negative 6. What's negative 6 minus 6? Can you take the log of a negative number? No. And even though, yes, the left side does indeed equal the right side, you cannot take the log of a negative number. So that means this answer is, and so your final answer is no solution.
So if your x equals a negative number, then it's
No, not always. That's why you always want to go back in and check, because depending on what was actually in the original problem, when you plug in that negative number, it might produce a positive number that's attached to the log. So you always want to check. So when you have logs on both sides, you want to make sure it's one log equaling to another log. Set the arguments equal to each other, solve, and check. Questions? If they're not the same base, then more than likely I made a typo, and you want to ask me. But it should not. They should be the same base. Then there was an error somewhere. Trust and believe. Trust and believe. In my years of math, they've always been the same base. I take that back. You have to do something that's a little bit more advanced for this class. Some of y'all take SL or HL. You'll learn how to do that. Let's look at these. C and D. C and D. This is one of those situations where you have a log on one side, right? And it equaling to another number. So if we look at those directions where it says log on one side, you want to isolate the log and or apply properties to condense or expand. Well, for both of these, well, for this one, I don't have to condense or expand nothing. And the log is by itself. There's no additional 3 in the front or adding an additional number to that log.
Can you factor out?
No, you don't want to factor. Step 2, you want to write it in exponential form. Okay? What's the base in C? 10. So when I write this in exponential form, it's going to be, very good, 10 squared equals 12x plus 16. That's step 2. Step 3, you want to solve. 10 squared is? And then to solve for x, you want to do what? Subtract 16. What's 100 minus 16? So 84 equals 12x. And then you do what? Divide by 12. What's 84 divided by 12? 7. Okay? I probably shouldn't have circled that. What do I need to do? Check. Check. Plug it back into your original. Okay? Now, just as a heads up, all of these problems, except for that last section in this foldable, can be done without a calculator and should be done without a calculator. Okay? Nothing too crazy. 84 is divisible by 12. When I go to plug it back in, I have the log of 12 times 7 plus 16, equals 2. We know that 12 times 7 is 84. 84 plus 16 is? So I have a log of 100. What's the base? 10. That's supposed to equal 2.
Oh, yeah,
10 squared does equal 100. If I have log base 10 of 10 squared, don't that log base 10 of 10 cancel out? That's one of those special rules. So then that does indeed equal 2. So it works. If I go back to the properties from the other day, those special ones, where are they? Where are they special? There it is. Right here. That was this property right there. Log base b of b to the m. You just left with m. And there you go. Questions? So far, so good. Okay. Let's look at this one. Is the log by itself?
No.
It's not. This one is when the log is on one side. It's not by itself. There's a 3 there. My suggestion to you, get rid of it. How do I do that? I would divide by 3. Dividing by 3 makes this problem a lot easier than trying to bring it up as an exponent and then rewriting it, okay? Because now I got a cube, and then we got to deal with that. So if I divide by 3, this gives me log base 8 of 9x plus 10 equals 2. Excuse me. Because the 9x plus 10 is attached to the log, so technically you're taking the log of whatever that number is once you plug it in. So it only applies to the outside. Now I need to write in the exponential form. Let's loop. So it becomes 8 squared, which is 64, equals 9x plus 10. 8 squared is 64 again, like someone said. How do I solve? Subtract the 10 over. So that gives me 54 equals 9x. And x equals 6 because I divide by 9. A quick check. What's the 6 times 9 plus 10? Okay. 64 can be rewritten as 8 squared. And then using that same property from before, this just becomes 3 times 2, which is 6. So it works. Questions up to here? Okay. So keep looking at some examples with E and F. We have 2 logs here. What are we going to have to do with this? We're going to have to condense using what rule? Multiplication, because it is an addition. So this turns into x plus 21 times x equals 2. Well, what's x times x plus 21? So this becomes x squared plus 21x equals 2. Okay, all of that's with the log. Now we have just one log on the left side equaling a number, so we need to rewrite it. Exponential. What's my base? 10. So this is going to be 10 to the second equals x squared plus 20. Oops, I forgot my whole x on that one. Nobody's saying nothing. Jesus. So this becomes 21x equals 2. So it's like that. I apologize. 10 squared is what? I heard a wait. Oh, because it was the base. Because it's a common log. So this becomes 100 equals x squared plus 21x. What do you see? It's a quadratic. And how do you solve a quadratic? Set it equal to 0 and factor if you can, okay? To be honest, all of these, we're going to make them nice for y'all and make them factorable. So I subtract over the 100. And I'm looking for 2 numbers that multiply to give me negative 100, add together to give me 21. All right, 25 and 4, what are my signs? I have to set both of these equal to 0. So x equals and positive 4. And you sure do. You got to make sure that you check them, okay?
So, can they both be right or one of them be extraneous?
They could both be right, yes. One could be extraneous. They both could be extraneous. So you want to check both. When I plug negative 25 in, this becomes negative 25 plus 21. What's that? So I have a log in negative 4. Can I have that? No. So this one's out. Let's plug in 4. What's 4 plus 21? 25. So I have a log 25 plus a log 4, and that's supposed to equal 2. Condense this. Addition means what? So this becomes log of 100, and just like before, we literally did one just like this. This is equal to 2. So only 4 is my answer. Yes? You could definitely write in exponential form using that base. 10 to the second equals 100. So then it checks out. Yeah. Now it looks like a V. Okay. Can you guys give this one a try? Okay. Give this one a try. You are solving F. So for this particular one, we have to condense it, just like the last one. Using what? Using quotient. So this turns into log base 4 of 5 over 2x. Now that you have just one log on one side, you can rewrite it in exponential form. Remember, start with your base, loop around, So then it becomes 4 to the equals. How do you solve this? So it becomes ax equals 5. So then x equals 5/8. Okay? When I go to check, this becomes log base 4 of 5 minus log base 4 of 2 times 5/8. What's 2 times 5/8? Give it to me now as a fraction. Not as a decimal, I mean. Give it to me as a fraction. 5/4? Okay, 5/4. I want to make sure that this equals 1. Subtraction means, so I have 5 divided by 5/4. Yet again, another fraction within a fraction. Keep, change, flip. This turns into what? Which just equals 4. What's log base 4 of 4? And it works out. Question? You multiply both sides by 2x to cancel this out. So you get 8x equals 5, and then divide both sides by 8. Okay? This is how you solve a logarithmic equation. All right? Logs are used to solve exponential equations as well. Ones where you cannot rewrite with the same base. Okay? That's what this last little flap is for. All right? So, when you're solving these exponential functions that don't have like bases, or you can't rewrite them so that the bases are alike, okay? Just like with a logarithmic function, with the exponential one, you want to isolate the exponential expression. So where's the variable? You want to get that part by itself on one side, nothing else. Then you want to take the log or the ln of both sides. It doesn't matter which one you take if it's just regular numbers. Okay? There are certain situations where you have to use ln and not log. If you want to just keep it consistent, then just take the ln of both sides. You get the same answer whether you use log or ln. Okay? And then the last step is to what you think. Blank for the variable. Solve for the variable. Okay? So we're going to solve for the variable. So, easy question here. Step 1, isolate the exponential expression. Here's the variable. It's attached to the 4. I need that term to be by itself. So that -1 that's there, I got to get rid of it. What do? Add it over. This is how you isolate the exponential expression. Because the variable, which is x, is there is attached to the 4, so that has to be by itself. At this point, you want to do step 2. It says take the log or ln of both sides. It doesn't matter. If you just want it for consistency's sake, you can just do the ln each time, okay? You get the same answer whether you use log or ln. All right? And what I mean by taking the log or ln of both sides, that literally means write log or ln before each side. Huh? It will be a common log. For x would be the argument, yes. Okay? Now, you're trying to solve for x. Okay? We're trying to solve for x. So now that we've taken the log of both sides, we can apply the power rule, which says that when there's an exponent in the front, or in the exponent, we move it to the front. So this becomes x times the log of 4 equals the log of 17. And then to get x by itself, since this is x times the log of 4, we're going to divide both sides by the log of 4. And then this would be our answer. We can type this into our calculator and get a decimal approximation. Of course, round to 3 significant figures. Okay? Or you could just leave it like this. Okay? Either one would be acceptable. Now, if I say round to 3 significant figures, then yes, I do want you to use your calculator. Does anybody have their calculator near them? Okay? When you type this in, especially on these calculators that I have here, you got to go backwards. 17 log divided by 4 log enter. Okay? And then you'll get the decimal approximation for that. It's not going to have a base. So when you take the log, it is a common base because it allows you to do it in your calculator. Okay? Questions? Let's look at this one. Is the base by itself or is the exponential expression by itself? Yes, it is. There is a plus 1 up there, but I can't get rid of that plus 1 without doing some other stuff with the x. So technically, this is my exponential expression, so that is by itself. Now, what do I need to do? Take the log of both sides. Log or ln, doesn't matter. You'll get the same answer. When I take the log of both sides, this is what I have. It is a common logarithm, so that's a base of 10. And just like before, I can take that exponent and do what with it? Bring it to the front. And just like before, it's being multiplied to that log of 8. Which means to solve for x, please don't distribute. Don't distribute here, okay? Yes, you can distribute, but that just means more work at the end, okay? To solve for x, how can I get rid of that log base 8? Divide it. If I divide both sides by log of 8, I get x plus 1 equals log 3 over log 8. And then I subtract 1 from both sides to actually solve for x. And I just looked up and I saw that I have calc here, so I do want you guys to use your calculator to get this answer. Can you guys type this in for me and get an answer? Again, you'll just press 3 log divided by 8 log, enter, enter. If you don't have one of those types of calculators, you can just type it straight forward. And you would subtract the one after that, yes. What did you guys get? Negative 0.472. 3 significant figures. You're going to give me a decimal approximation, okay? So you start with your first non-zero number and then count 1, 2, 3. Now, there are no restrictions with an exponential equation. Because remember, the domain of the exponential function is negative infinity to positive infinity. Okay? So whatever value you get, that's your value. Questions? Let's do some practice, okay? Let's do some practice. I want you guys to try this. This particular problem, you want to, it's 1 log on one side, which means you have to isolate it. It's not by itself. This logarithmic expression term has a -7 attached to it, so you got to get rid of that. What do? So then this becomes log base 2 of x minus 9 equals 3. Now that you've isolated, you have to rewrite it in exponential form. 2 to the third power equals x minus 9. What's 2 to the third power? Equals x minus 9. So x equals, check it. When you go to plug it back in, this becomes log base 2 of 8 minus 7. Now that log and that base only goes to the 8, which means that when you're trying to see if this equals -4, you do this part first, and whatever number that is, you subtract 7. Evaluate the law. We practiced that on Tuesday. 2 to what power gives me 8? 3 minus 7 is, so it works. Okay? Clear your desk. See, we're running out of time. I want to do this one for sure. We're going to do this one together. I want you to add this to your notes. Add this to your notes. Okay? Now, this is a natural log. And if you were here on Tuesday, and when we first were introduced to these, I said, this is a natural log. It's just like a logarithm. However, log works for any numerical base. Okay? But natural log goes with a certain type of exponential function. That was the e. Okay? Y'all remember me talking about e? That's the same reason why in one of those special rules, ln of e is equal to 1. They cancel each other out. Okay? You're going to need the e to solve a natural logarithmic equation, especially when it's not like a log equaling a log. Okay? Here, same rules apply though. You need to condense. When I condense this, it turns into what? Subtraction means, so this becomes x minus 6 over x equals 3. So you condense it, remember, subtraction means division. Now, step 2 says you need to rewrite it in an exponential form. Unlike a log that has a numerical base or has a base, this is a natural log. Its exponential counterpart is the e. So when you rewrite this, e is your base. I'll say that again. This is a natural logarithm. It has a specific base, and that is e. So when you rewrite this in exponential form, you already know that your base is going to be e, and you still loop the same way. Okay? This is going to be e to what power? 3 equals x minus 6 over x. Now again, e is a particular base. It's like 2.71728 and it goes on forever. Okay, so this is an actual number. But because it goes on forever, we cannot represent that full decimal. That's why we use e. And now we solve for x. At this point, it just becomes some algebra. You multiply both sides by x. And if you're curious, yes, that turns into x e to the third power equals x minus 6. Is everyone okay up to here? All right. And we are solving for x. I know there's another variable in there, but remember, e is a number. I'm solving for x. I have an x on the right-hand side that needs to join this other x over here. So what am I going to do? Subtract it. Now, I cannot just subtract them the way they are because, again, I don't know what e is. Definitely not what e to the third power is. But one skill that I can use is, since I have two terms and both of them have an x in common, I can factor out an x.
Why did you just add 6?
If I would have added 6, I would have had my variables would still be on two different sides. And when I'm solving them, I need them to be on both sides. And now that I factored out the x, I can solve for it by doing what? Dividing by that entire expression. I feel at this point we have reached algebra 2. And that's your answer. So let's recap. Same steps as before. Those 4 steps. I think it was 4 steps. You isolate and or condense. We did that. Then we rewrote it in exponential form. And again, because it's a natural log, automatically the base is going to be what? E. So when we rewrite in exponential form, it becomes e to the power of 3 equals x minus 6 over x. After that is algebra. We're trying to solve for x. That's the variable. We subtract the x over, and we factor it out. You cannot combine x e to the third minus x. Once we factor out, we're able to divide, and yes, that is our answer. Remember, e is a number. Questions? No. I don't expect you to plug that back in. Yes? ln will never have a base. It will always be e. So whenever you see ln in the exponential or in a logarithmic problem, and it's not one where it's like ln equals ln, where you can just cancel them out, then you need to use e. Okay? So